In this work, we present a systematic solution for visibility-aware cooperative tracking using LiDAR swarms. In the following experiments, all navigation modules are fully decentralized and run entirely on board. The swarm operates in unknown environments, tracking passive targets without any communication between the target and trackers. The target states are obtained solely from onboard LiDAR measurements. In this test, the swarm tracks an agile target drone in a dense forest. The swarm has 4 drones with heterogeneous ladders. The detailed LiDAR configurations and the corresponding legends are shown on the right. Four drones are tracking the target in the forest. The individual views of each tracker are displayed at the bottom, with FOV states visualized. The SSDF, spherical sign distance fields, are constructed for preserving visibility, as shown in the RV's window. The swarm forms a 3D tetrahedron distribution to track the target, agilely avoiding potential collisions and occlusions. In this experiment, the swarm cooperatively tracks a human runner, moving in a playground with obstacles. The LiDAR configurations of the swarm remain the same as in last experiment. When the target runs through a gate, the trackers flexibly compress the distribution to traverse the constrained space and maintain full target visibility. When the target is walking through pillar obstacles, the swarm agilely rotates the distribution to avoid occlusions. To showcase the dynamic reconfigurability, we conduct a tracking experiment where the swarm members join and leave dynamically. The LiDAR configurations of the swarm and the legends are shown on the right. The target drone starts moving, and the mission begins. The swarm of UAV 1 to UAV 3 is trying to find the target. Once the target is detected, the swarm starts cooperative tracking and forms a triangular distribution around the target. As the target proceeds, the isolated UAV-4 detects the target. It firstly performs solo tracking, and the swarm calibration starts. Once the calibration is finished, UAV-4 joins the swarm and then forms a 3D tetrahedron encirclement with its teammates. Here, UAV-2 drops out. The swarm reconfigures the tracking distribution to a regular triangle. Then, after UAV-3 leaves, the two-drone swarm further transitions to collinear target encirclement until the end.